You know, integration by parts. So sometimes you can avoid integration by parts by doing a dx dy versus a dy dx. It's funny. Easy to look at it. Look how the problem is. Cool. Hey, nice. Hey, one of the last things I want to do is talk about how we can reverse the order of integration to do an integral. And a good example is like, this is like textbook 15.3. I'll probably even start one like this tomorrow. Page 996, this is problem number 49. Just because I like to give you a lot of practice on this. They call this reverse the order of integration. It's in 15.3. Reversing the order of integration. Why do you want to do that? So I thought I'd give you a problem where it was necessary. But if we did it one way, our methods that we're knowledgeable of, integration by parts and u subs and partial fractions, it wouldn't work. So I'm going to put letter A. Here's the setup. Reverse the order of integration. They've got 0 to 1. 3y to 3, e to the x squared, dx dy. By doing a point out, you'd be, told to do this during the test. But you can study it carefully. Why would this be necessary? This would be trouble, wouldn't it? Does anybody know how to integrate e to the x squared? No. E to the x squared with respect to x. Integration by parts doesn't work. U sub doesn't work. Partial fraction doesn't work. Trig substitution doesn't work. You have to go to like a power series method or something to get that thing going. But the whole idea is, man, what if we reverse this? And by reversing, we're talking about take dx dy and change it to what? dy dx. So when we do this, and we're going to reverse, this will be letter A, B. This will be letter A. And how about letter B? Let's evaluate the double integral, which I can just call the integral. So we're going to start out by reversing this. It's hard to just do this by staring. So when I see a student get this wrong in a test, I look for work and I go, now I know why they missed this. I see no picture. We got to draw a picture, not the surface. That's going to stay put. We need to draw this region of integration. So can we draw this? Let's draw this thing. What does that look like? Make a really decent drawing. All right, start out. These numbers, are they y's or x's? And I marked this thing up when I include you do this thing. Let's mark this up. Are these y's or x's? So they're y's. So I'm like, okay, your y equal to 0. And your y equal to 1. So I start marking this thing up. Your y equals 0. Your y equals 1. What are these? Oh, your x, and this is an equation. You're a curve. And your x equal 3. That's a line. What I need you to do is shade the region between these two curves. I need this shade between here, and how far? I'm going to put the word from this value to that value. I'm marking this thing up. I need you to go in here, and because I don't want you to shade the wrong region. And I'm going to mark this thing up. I need to shade between x equals 3. What does that look like?
Straight line.
That's a straight vertical line. You need to shade between that line and that's another line, by the way, x equals 3y. Shade between them, but how far? Go from y equals 0 to y equals 1. So when this is my, remember right and left? Because dx what? You're my right side and you're my left side. You agree? So I heard it. On the right, you got x equal to 3. Now what's this? Everyone x equals 3y on the left. I'll go to the left.
So y.
I think it's easier if I solve for y. What would y equal?
X over 3.
Yeah, 1/3 x, so I can see the rise run. The rise run, rise 1, run 3, and it goes from the origin, right? So in rise 1, run 3, and eventually you're going to hit that nice line. There you go. There's my left, you're my right. See that? You're on the right side, you're on the left side. Right side, left side, shade between the right side and left side. So where am I shading? Oh, and they said go from y equals 0 to y equals 1. So this is the big dilemma. Do I shade in here
No.
or in here? Shade between these. Shade between that and that. Everyone see where you're shading? Does that agree? Alright, so I just want, it's so important, I don't want you to be shading the wrong region. Like, man, why did I miss this problem? You shaded over here by accident. What happened? We think who's right, who's left, shade between. So there it is, now let's reverse this. What do you get? Does this get reversed? No, that stays what? E dx squared. But this gets reversed. dx dy becomes dy dx. Now, I bet you can do this. What are these? They gotta be numbers. They gotta be x values, and they gotta be numbers. The outer limits have to be integers. I shouldn't say integers, they can be fractions, they just gotta be numerical. There you go, he's looking at the image. That nice picture you drew is gonna tell you. Go from 0 to 3. Now, is this right, left, or top, bottom? This is top, bottom, because it's dy dx. We're thinking who's on the top? Who's my top equation? Who's my bottom y equation? All right, who's the top equation? It's that funny slanted line, 1/3 x over 3. Oops, sorry about that. X over 3, who's the bottom? Y equals 0. And for the last thing today, I want, please just solve that. Because you know I can't split this up, right? The last thing, we're going to evaluate this. Let's start here. Integrate that with respect to y. So here comes part B. We're now going to solve this. Oh, that's easy. What's the integral of e dx squared with respect to y?
Just multiply by y.
Yeah, look at that. That was easy. And you're going to plug in what for y? A 0 and a something. Go ahead and substitute the x over 3. Substitute the 0, and I get x over 3 e to the x squared. I love zeros. You plug in a 0, you get 0. So, for the final thing today, everyone, how the heck do I do that? Man, you're good. That was quick. Good eye. They knew you needed use up here. Your eyes saw the x squared versus x to the first. Hey, that 1/3, you want to jam that out of here? I don't care. I'll do it. Let's put the 1/3 out here. And then I'm going to do this use sub like everyone suggested. Right here. Here. Let u equal x squared. du equals 2x dx. 1/2 du equals x dx. I do want to point out, if you're rusty on u subs, but you get a lot of practice in this chapter. We get a lot of u subs popping up here and there. So what am I substituting? The half du replaces the x dx. And I get 1/3 times a half, which is what? 1/3 times a half is 1/6. Integral symbol. The x dx got replaced by just a du. And what's this become? Hey, I'm keeping this blank, because these are u values. So I can't write 0 to 3 here. You can leave them blank, resubstitute, and then put the numbers 0 and 3 back in. Does anybody like to change the limits of integration? I'm looking around. No, no one does, so I'm not going to do it. But I could change these. All I'd have to do is substitute a 0 and 3 into what? Like, what's 0 squared? 0. What's 3 squared? None. So if you like to do that, great. But I saw a lot of people go, no, I wait. So I'm going to, what's the integral of e du? The integral of e du is?
E to the u.
E to the u. And now put your u back. I heard everyone say wait and just resubstitute and go from 0 to 3. So what's this answer?
E to the power
1/6. I'll put a parentheses.
E to
E to
the
the 9th.
minus 1.
Good. E to the 0 is just a. You just leave it like that on your problem sets or your tests. The one I have in a practice set, there's one like that.